Welcome to our mathematics class. This is part 3 of our basic examples using trigonometric functions. Let's look at example number 3. If 3 times cos alpha minus 2 is equals to 0, and alpha is between 0 and 90 degrees, then determine the value of each of the following. 1. Tan alpha times cot alpha, sin alpha times cosec alpha, cos alpha times sec alpha. Now let us look at the solution. 3 cos alpha minus 2 is 0. We need to write this in the standard form of trigonometric ratios. Then we transpose 2, we move it to the right. It becomes 3 cos alpha is equals to 2. Then we divide by 3 on both sides. Then cos alpha is equals to 2 divided by 3, which is now in the standard form of our trigonometric ratios. And then we know that cos alpha is adjacent of hypotenuse. That will imply that our adjacent side is equals to 2 units and hypotenuse side is 3 units. Then we put that to a diagram. Our adjacent is 2, our hypotenuse is 3. Now we need to determine the opposite side of the triangle. Now we can use that. You can use Pythagoras to determine the value. Applying Pythagoras theorem, ab squared plus ob squared is equals to oa squared. Then we make the opposite side, which is AB, the subject of the formula, where now AB squared becomes 3 squared minus 4 squared. Applying our knowledge of exponents, we get that AB squared equals to 9 minus 4, and the difference now is 5, so AB squared equals to 5. Then finally we get that AB is equals to the square root of 5. Therefore, our opposite side is root 5 units. Then we can go ahead now to determine what we are requested to determine or to calculate. Tan alpha equal times cot alpha. Now let's get our diagram updated with the opposite side being root 5. Then we can be able to draw our values from the diagram. We know that tan alpha is equals to opposite over adjacent, and cot alpha is adjacent over opposite. Then we substitute the values. Tan alpha would become root 5 divided by 2, and then cot alpha would become 2 times root 5, and that comes to 2 root 5 divided by 2 root 5, and it yields a value of 1. You would remember that tan alpha and cot alpha are reciprocals, so multiplying 2 reciprocals, you always get a 1. Example number 2, sin alpha times cosec alpha. Now let us use our diagram to be able to draw the values from it. Sin alpha is equals to opposite over hypotenuse, and cosec alpha is hypotenuse over opposite. Substituting the values, the opposite is root 5, hypotenuse is 3, so sin alpha would be root 3 over 5, and the hypotenuse on the side of the cosec would be 3, and the opposite would be root 5, so cosec alpha would be 3 over root 5. When we multiply the 2, we get 3 root 5 divided by 3 root 5, and that yields a 1. And again, we know that sin alpha and cosec alpha are reciprocals, so their product will always yield a 1. Let us look at cosec alpha times sec alpha. We will also use the diagram again to draw our values from it. Cos alpha is equals to adjacent divided by hypotenuse, and sec alpha is hypotenuse divided by adjacent. Substituting the values, adjacent value is 2, the hypotenuse side is 3. Then when we multiply the 2, that will yield 6 over 6. and that yields a 1 also, because cos alpha and sec alpha are reciprocals. So this was more of a confirmation of the lessons that we have learned. This is the conclusion of our example. So I'm looking forward to meeting you again in the part 4 of our examples. Have a good day.